Network level session hijacking. The network level session hijacking relies on hijacking the transport and internet protocols used by web application in the application layer. By attacking the network level sessions, the attacker gathers some critical information which are used to attack application level sessions. So before going to the network level session hijacking, it is important to understand the three-way handshake of the TCP/IP protocol. So here, when the client initiates the connection, the client will send the ISN number, initial sequence number, and it will set the SYN flag. At this point, the client will be in the SYN sent state. When the server receives this packet, server will be in the SYN received state. So after receiving, it acknowledges the client with a sequence number and sends its own ISN with the SYN flag set. So this is the SYN ACK message. The client acknowledges the server sequence number by incrementing it and setting the ACK flag. Now the client will be in the established state. On receiving the client's acknowledgement, the server enters into the established state. So now both the client and the server are in established state. The connection can be closed either by using the FIN or RST flag or through a timeout. If a RST flag of a packet is set, the receiving host can be server or a client. So this RST flag can be sent by both a client or a server. So the other guy will enter into the closed state and freeze all the resources associated with this connection. This leads to the connection drop of many additional incoming packets. Okay, next, if the packet sent is a FIN flag, then the receiving host closes the connection because it enters to the closed wait state. Notice the difference. For reset, the state entered will be closed state, but the FIN flag, the state will be closed wait state. The packets sent by the client are accepted in an established connection if the sequence number is within the range and follows its predecessor. So the server will accept the message from the client only if the sequence number is in within the range, and it should be somewhat in a relation with the previous sequence numbers. If it is completely out of sync with the previous sequence numbers, then the server might discard the packets. So if the sequence number is beyond the range of acceptable sequence number, the server drops the packet and sends an ACK packet using the expected sequence number. So it says you have sent a wrong sequence number. This is what I was expecting. So it will also send the expected sequence number. So for the three parties to communicate, the following information is required: IP address, port numbers, sequence numbers. So it is easy for an attacker to determine the IP address and port numbers. These are available in the IP packets which do not change throughout the session. However, the sequence numbers change. Therefore, the attacker must successfully guess the sequence number for a blind hijack. If the attacker can fool the server into receiving their spoofed packets and execute them, the attacker is successful in hijacking the session. So let's see what is a TCP/IP hijacking. So the steps that are followed in the TCP/IP hijacking: the attacker sniffs the victim's connection and uses the victim's IP address to send a spoofed packet with the predicted sequence number. So here he is pretending to be a victim by spoofing the victim's IP address. The receiver processes the spoofed packet, increments the sequence number, and sends an acknowledgement to the victim's IP address. The victim machine is unaware of the spoofed packet, therefore it ignores the receiver's machine ACK packet and turns off sequence number count. Consequently, the receiver receives packets with incorrect sequence number. The attacker forces the victim's connection with the receiver's machine into a desynchronized state. So the victim keeps on sending out of sync sequence number, and the state will be desynchronized. So the attacker tracks the sequence number and continuously spoof packet that originate from the victim's IP address. The attacker continues to communicate with the receiver machine while the victim's connection hangs.